Hi, Angie's back. We're going to go ahead and start on Chapter 10. So the first section, 10.1, I haven't messed with my focusing here. Hopefully that's visible to you guys. 10.1 is dealing with, in general, radical expressions and functions. So kind of an overview starting with some things you already know. So the first thing you already know about is a square root. So since I know that you know about it, we're going to go ahead and add a little bit into it. So by definition, C is a square root of A if C squared is A. Okay, so C is a square root of A if squaring C gets us to A. I know it seems kind of like it's like, well, isn't there an easier way to say that? Yes, but if we have this as our definition, then it lets us talk about positive numbers and negative numbers in a different way. So let's go ahead and look at these next two questions I have. So is the number 5 a square root of 25? Does it fit this definition? If I square 5, do I get 25? I do, so it is. So the answer is yes, yes it is. Okay. What about this next one? Is negative 5. Notice I've put it in parentheses. I think you're learning by now, me and parentheses, we're very fond of each other. And I'm using parentheses because it's a negative number. So is negative 5 a square root of 25? So if I square negative 5, now be careful. I'm talking about squaring the entire number, negative 5. Is negative 5 squared 25? It is, right? Because you remember that a negative times a negative is indeed a positive. So negative 5 is also a square root of 25. Okay, now I'm going to take a little pause here. Pause. No, don't hit the pause button. But I just want to show you something on your scientific calculator. So I'm going to go ahead and move this paper, put the calculator up. And I want to show you some keystrokes and what you need to do. Because if you just grabbed your calculator to do negative 5 squared and you didn't use parentheses, watch what happens. So that to make it negative, you use this button down here. It's a little negative sign inside parentheses. So negative 5, and then if I square it, it's not going to say positive 25, it says negative 25. But that's because Texas Instruments knows its order of operations, and it does the squaring on the 5 first, and then this negative sign. It's like a negative 1 times 5, right? If you really meant the entire number negative 5 to be squared, then the way we do that is with these parentheses here. So we could, if we didn't want to do it in our head, and I might mock you just a little bit if you don't, but if you say, oh, I feel more comfortable if my calculator does it for me, fine, just be careful. So here's how we make our calculators do it carefully. So parenthesis, negative 5 square, there it is. So now there's our positive 25 because it takes the entire number negative 5 times another negative 5 to come up with a positive 25. Okay, enough of my aside, back to the lecture. So let's see. So since both positive 5 and negative 5 are square roots of 25, we identify positive 5 as the I think they call it principal square root. They might say primary. Vocabulary and I aren't the best of friends. So let's go ahead and identify some pieces here. So this symbol, right, we call the radical symbol, sometimes just radical. The number or letter underneath is called the radicand. Right now, there's nothing written in this little crook of the symbol, right? So when there's nothing written, it's an understood 2. When it's something other than 2, right, we have to write it in there. Anyway, that number, whether seen or unseen, is called the index. And the answer is called the root. or the square root? Okay, so here we go. Let's go ahead and practice. Oh, identify radicans match or not. Okay, so practice reading it out loud. What's this first expression? How would you read that? Right, the square root of x minus 3. What is the radicand? Right, so the radicand, the thing underneath, is the expression x minus 3. Okay. What about the second one? What is that? The square root of 25x cubed. So the radicand is, right, just that part underneath, 25x cubed. So what's the index for both of those? What is that little number, seen or unseen, in the little crook? Right, 2. Right, so these are both square roots. Okay, so I have a little star down here. So where was my star up here? Oh, we identify positive 5 as the principal square root. We won't do this for a very long... Oh, we won't do this for very long. That's right. Okay. We automatically go with the square root, right? If I ask you, hey, everybody, what's the square root of 9? You automatically just say 3. You automatically give the principal square root, the positive one. Okay. So it's sort of a lead into chapter 11 when we use the square root property and we find the positive and the negative root for solutions to quadratic equations. So you have to know that there are really 2, but when you're asked for just, right, to evaluate an expression, then you only give the positive one. Okay, so try to let it wash over you for now. 10.1, there may be some times when we have to slap some absolute value symbols around our answers. I'll try to let you know when that is and what to look out for. But after 10.1, it really goes away. Okay. In chapter 11, I'm going to bring it back just a little bit when we go and we use the square root property to solve quadratic equations. Okay? So try not to get too hung up on it. It's not that big of a deal to me. But it is going to be there in your My Math Lab homework. I tried to screen them all out, but I'm not sure I got them all. Okay, so here we go. Page 2 of our notes. Make sure we're on there. So, square root functions. So here's an example. So remember, we have our function notation, f of x equals the square root of x. So again, here is our radicand. Okay. So we'll talk about the domain as soon as we read my note. A square root function is only defined if the simplified radicand is non-negative. You'll notice me using some bigger words. Positive, right? Positive. We can only take square roots of positive numbers or 0. So that's why non-negative is, right, the fancy schmancy algebra way to say all the positive numbers plus 0. Okay, so this gives us a domain restriction, right? Functions have domains, right, what you're allowed to plug in. And if we restrict our radicand to be non-negative, that means it has to be that radicand has to be greater than or equal to 0. That's all we're allowed to do in our radical functions. So let's go ahead and write the domain of this f of x equals the square root of x. What can x be? Right? Well, I take the radicand, and then I set it greater than or equal to 0. In this case, I don't have anything else to do. That's all there was, and now I know. So there it is. If we wrote that in interval notation, we'd start at 0, we'd put a bracket on it to say we're including 0, and it's every other number all the way out to infinity. Okay. So here are some that aren't quite so basic. Let's practice finding the domain. So I'll do the first, well, I'm going to do all 4 of them. Why don't you watch me through the first one, and then if you want to hit pause and try the next 3 and see how you do, and you can come back and check. Okay, so domain of f of x equals the square root of x minus 5. So I need the radicand, which is x minus 5 to be greater than or equal to 0. Okay, and now we go in and we solve for x to figure out what x values we're allowed to use. So how would I solve for x in that inequality? Right, we'd add 5 to both sides. So now I have x is greater than or equal to 5. That's our domain. I was going to say solution set. Those are the x values you're allowed to plug in. So we start at 5 with a bracket because it's included, and we'll go all the way to infinity. That's the domain. Okay, so if you want to go ahead and pause and try the next ones, I'm going to do the exact same thing. So if g of x equals the square root of 7x plus 3, we grab the radicand, set it greater than or equal to 0, and then we solve for x. So it looks like the x's that are greater than or equal to negative 3/7. Still on screen there. So we'll start at negative 3/7 and go to infinity. Okay. 9 minus 6x is my radicand. It has to be greater than or equal to 0. So we solve for x again. Okay, oh, I have to divide by a negative 6. Remember what happens? So the inequality flips its direction. And then I also have a negative divided by a negative, so those will be positive. And the fraction reduces, so we'll go ahead and do that. So I need the x's less than or equal to 3/2. So if I'm less than, that means I start down at negative infinity, and I go up till I get to 3/2, and then I stop. Okay. Last one. So k of x equals the opposite of square root of x plus 2. Well, that negative sign, right, is really only affecting the outputs. It doesn't get inside the radical. So you just grab that radicand, x plus 2, and set it greater than or equal to 0. So this time I need the x's greater than or equal to negative 2. So starting at negative 2 with a bracket and continuing to infinity. Okay, so let's see, what do I have here? Let's practice evaluating radical functions. So f of x equals the square root of 4x plus 8. And if I ask you to find f of 0. So you'll remember from chapter 7, we replace all of the x's with this value. So I'll have 4 times 0 plus 8. Well, anything times 0, 0 plus 8 is 8. So I have the square root of 8. So this is called an exact answer. Okay, this is the one that I'm going to be looking for almost all of the time. An approximate answer we can find on our calculators. So I could take the square root of, I'm looking for my square root symbol, 8, and get an approximate answer of 2.83 if I round. Because I stopped writing those, they ended. And with the radical symbol, it's the exact. Okay, go ahead and try the next 3. Oh, f of 2 is 4. So I want to keep going because this 4 is also a nice already taken the square root, so that's all there is to do. Go ahead and circle those guys up. Okay, so f of negative 2. Remember, I placed the x in my expression, my function, with the value that's inside the parentheses after the function name. 4 times negative 2 is negative 8, plus 8 is 0, so I have the square root of 0. That's so for now, and until 10.8, we're going to say, oh, we can't do that. That does not exist. Okay? So does not exist in the real number system. Okay, 2 more pages. So again, this kind of goes along with that asterisk that I 1.1. Okay, after this in chapter 10, they won't make you do it. You don't do this if so what operations E thing? If I had the square root of negative 5 squared, okay, we can't just have the square root and the squaring cancel. We need to, well, we can, but then your answer is in absolute values, right? You can't just take that out and have a positive principal root. Okay, so again, it's just in this section. So right here, square root of 5 squared is the absolute value of 5, which is 5. Okay. Square root of negative 5 squared is the absolute value of negative 5, which is, okay, typically it's when we have these expressions. So here's one. Square root of 81x squared. Okay, so that's the square root of 9x quantity squared. And so that would be the absolute value of 9x. So if you can get that radicand to be something squared, then right, the square root and the squaring kind of cancel as long as that radicand goes in some absolute values. Now, since we already know what 9 is, we could bring that out and just leave the x behind in the absolute values. Okay. Okay. Oh, I love this one. Square root of x squared plus 18x plus 81. Careful. We can't simplify radicals, and we'll learn a lot more about this in chapter 10. We can't simplify across pluses and minuses. It's not allowed. But you'll find this in your homework someplace. Can I write that radicand as something squared? Well, if you're recently out of Math 98, you can, right? This is going to be x plus 9 quantity squared. Okay, so now I have a square root of something squared. So what that is the radicand. But now since the radicand has a variable in it and we don't know if it's positive or negative, we go ahead and put that absolute value around it. Okay. And then our last one on this page is the square root of x squared plus 81. Okay, I'm being totally tricky. Guess what? There's nothing we can do about it. There's no simplifying. So it doesn't simplify. That's all there is right there. Because of that plus right there. This is not x plus 9. It's not that. We don't go term by term. Okay, we can go factor by factor, but not term by term. Okay, let's go ahead and jump into that last page. So other indexes or indices, I don't know how I'd actually pluralize that. So cube roots is if that index is 3, that's what we say. So f of x equals the cube root of x. So here's the funky definition. If b cubed equals a, then the cubed root of a equals b. Did I say that right? If b cubed equals a, then the cubed root of a equals b. Okay. So if I can write the radicand as something cubed, then the cubed root and the cubed will essentially cancel. So let's see. Can I write 8x cubed as something cubed? And you're saying, yes, probably, Angela, or you wouldn't have put it here. So what would that be? 2x cubed, right? 2x times 2x times 2x. So 2 times 2 times 2 times x times x times x. So there's the 8, there's the x cubed. Okay, so it is true. So if I have the cubed root of something cubed, then that simplifies to just 2x. No absolute values. It's down here at the bottom. Okay. How about this next one? The cubed root of negative 125y cubed. Oh dear. So I have to have something that if I multiply it by itself 3 times, I get negative 125. Well, negative 5 would do that. And if I multiply, let's see, y. So let's try that. Does this get me back here? Let's see, negative 5 times negative 5 times negative 5, negative 125, y times y times y, y cubed, indeed. So now I have the cubed root of something cubed, so I get out the entire part, the negative sign as well. So here's how it is. For odd roots, we'll do that because we just talked about the cubed root. Odd meaning the index is odd. So for f of x equals the nth root of x, where n is odd, x is a real number, and the result has the same sign as the definition. Okay, so this means there are no domain restrictions for odd roots. Plug anything you want in, take the cubed root or the 5th root or the 7th root of any number at all, and the result you get out has the same sign as what went in. So up here, the ones we just did, if your radicand is positive, your answer is positive. If your radicand is negative, your answer is negative. Okay, that only happens when you have an odd root. Okay. Now, if you have an even root, f of x equals the nth root of x where n is even, like square root or 4th root. Okay, then we write, this is our domain restriction, that the radicand has to be greater than or equal to 0, and the result is the absolute value if the radicand has variables or a negative number. Okay, absolute value, just 10.1. Here we go. So let's go ahead and practice. Take a breath. So our first thing we need to look for is the index even or odd? So I have the cube root of negative 216. Even or odd? Odd, right? So my result is going to have the same sign as my radicand. Now, does anybody know the cube root of 216? I'm pretty sure it's 6. So negative 6. Okay. What about 2? I have the 4th root of negative 7 to the 4th. So I have an even index, but my radicand is a negative number. So this is where I have my absolute values. And then we'll go ahead and simplify that to a positive 7. Okay. Number 3. There's my index, even or odd, right? Even. My radicand has a variable in it, so that means the whole expression goes in parentheses. Now, when I had the 9 times x in the absolute values, I was able to tease that 9 out in front just because it was already positive, so its absolute value is positive. So when you multiply, you can split them apart inside of a radical. If you're adding or subtracting, you can't. The whole expression has to stay under there. Okay? So on 4, there's my index, even or odd. 9 is an odd number. And the index and the power underneath match. So I just get that radicand, and I don't put the absolute values. It would be wrong to do absolute values because, right, it could be positive or negative. It does not have to be positive. Okay, we'll see what you can do on those. Hopefully they won't be too obnoxious. I just noticed that the volume might have been way too loud on that. Sorry about that. I'll try to tone it down for the next one.